Good day everyone. Now we'll discuss about how to transfer a block of data from one memory to the other. So as far as this video is concerned, we'll be dealing with four types of block transfer. The first one is internal to external, that is internal RAM memory to external RAM memory, external read-write memory, then external read-write memory to internal RAM, then from external memory to another external memory, like one series of external memory address to the other series of external memory address will transfer, and the last is from code memory to internal memory. These are the different memory transfer we are going to deal with. So here the basic idea that we'll have to think is, in case if we are given with a lot of data which has to be transferred, it will not be good if you are writing for each and every byte a separate instruction for fetching it. So we'll have to put inside a kind of a loop. So that is what we are going to do. So basically first we'll discuss with the algorithm. So here in 8051 microcontroller, the internal memory will have 8-bit address. So I'll be taking the 8-bit address as 50. So 50 to 55 I'll be taking. So here in 50 I'll be giving the size of the data that I'm going to transfer. So five different values I'm going to transfer. So that I've given, while 51, 52, 53, 54, 55 are all the datas. So each and every value that is available in the memory address from 51 to 55, I'll be transferring it to 4500 to 4504. So this 4500 is the memory address of external memory. So this has to be transferred to this. So that will be checking it out. So let us get into the Kale. So as we have done earlier, same procedure, project, new vision project, and you can type some name, click save, and click legacy devices and go to NXP and P89V51RD2. P89V51RD2, select it and click OK and click yes, overwrite yes. So you'll get the source group like this. Now we can click this new button to type the program. So now we are going to do with the program. So let us start with the program. So as far as this particular program is concerned, we'll have to initialize this memory address. So here in the internal you can see I have 6 elements, while in the external memory I have only 5 elements. So here this 50 is not the element that I'm going to transfer, it's the size. So that we'll have to keep it in mind. So 50, you shouldn't be misunderstood that it is one of the datas. So this is the size. So this size I'll be putting in some register and I'll be decrementing it whenever the transfer has got completed. So these are the elements, 51 to 55 are the elements. So first we'll have to initialize the memory address of the internal memory, MOV R0, hash 50H. So this is the internal memory address I have initialized in R0. Then external address I'll initialize in DPTR, hash 4500H. So now I have initialized the internal memory address and external memory address. Now I'll have to fetch the data. Data is like what is the size of the memory content that I'm going to transfer into accumulator. So MOV A, @R0. So here this is a new instruction that I'm using. So again, MOV A, @DPTR we have used. MOV X A, @DPTR we have used. So this is MOV A. So here it is like internal memory. When you are accessing, X is not required. So when you are accessing external memory, then you will be putting MOV X. So MOV A comma at the rate R naught. So 50 will be taken as the memory address, and from 50 the data 5 will be fetched into the accumulator. So after the data has been fetched into the accumulator, we will be moving that data into R1 register, MOV R1 comma A. Next, so we have done with the R0. So increment the R0. So 50, now it will get into the 51. Then I'll have to fetch the data, MOV A comma R0, A comma at the rate R0. Again I am fetching the second data over here. So here when I am making INC R0, R0 becomes 51. So the 51 data 8 will be fetched into the accumulator. Then the data has been fetched. Now we'll have to move the data into the external memory. So to do that, MOVX at the rate dptr comma A. So now the content that is available in A will be transferred into the 4500. Then after transferring it, we are supposed to increment the value of dptr. So I will put INC dptr. Then we need to check whether the we'll be making it inside a loop. So this process of fetching the data and transferring it into the external memory has to repeat unless the 5 data has been transferred. So it has to, the procedure has to repeat again and again till 5 data has been transferred. So what I'll do is I'll create a loop with djnz, decrement and jump if no 0. djnz means decrement and jump if no 0 with R1. So R1 will be decremented once and it will be checked whether it has gone to 0. If it has not gone to 0, then I'll repeat the process of incrementing the R0 and repeating the procedure of transferring the data. So djnz R1 comma L. So when R1 has gone to 0, so the transfer is complete, so we can end the program. As we have done earlier, we'll do this. Yes, jump L1. So to make the program come and end in this line, I have done this, then end. So now we'll save it. This is internal to external .asm. So I have saved it. Now we'll add the content. Click ASM over here and search for this INTU, internal to external. Yeah, it is there. Add and close. Now so we'll translate. So one error is there in the 9th line. Yeah, here we are supposed to put a comma. So comma can be included. djnz R1 comma L. So in case if R1 has not gone to 0, this instruction will make the program counter to go over here and this procedure will repeat again and again. So I am translating. So you're getting 0 error and 0 warning. Then build and rebuild. Now we'll get into the start stop debug session. So here view memory window, view memory window. So we are supposed to, as we are giving the data in internal memory, I'll type I colon 0x50. 0x represents it's a hexadecimal value. When you are putting 0x, it's not necessary to put h afterwards. So here I'll give the data 5 and 8 9 AB 21 55. 8 9 AB 21 and 55. These are the input, and for seeing it in the external memory, you can again click the memory window. Sorry. Yeah, you can again click a new memory 2 window. So that one is memory 1, this is memory 2. So in memory 2 we'll type x colon 0x4500. so this is external memory. So in external memory we are supposed to get the data. These are the internal memories. So now let us check the program. So first R0 is loaded with 50, that is the internal memory address. Then DPTR is loaded with 4500. Then you can see MOV A comma at the rate R0. So 50 is available in the R0. So 5 is available in the 50. So the 5 is transferred into the accumulator. You can see now this is a indirect mode of fetching the data. 5 has been fetched. Then 5 is moved into R1 register. Then I am incrementing R0. So R0 becomes 51. Now it is pointing to 8. 8 will be fetched into the accumulator now. 8 has been fetched. So 8 is transferred into the memory address available in DPTR, that is 4500. So let us check that. So you can see 8 has been transferred to the 4500. Then I am incrementing the DPTR. Then decrement R1. So R1 is decremented once, so it becomes 4. Then R0 is incremented, so it is pointing to the next memory address. So the next value is 9, that is being fetched. You can see 9 is being fetched. Then 9 is moved into the memory 2. So you can see 9 has been moved. Then subsequently DPTR is incremented. Then R1 is decremented and checked whether it has gone to 0. Then from 53 the data is fetched, that is AB, and AB is transferred over here. You can see. So subsequently all the values you can see that appears whenever it goes on. So now it has come to the end. So R1 has gone to 0. So after this there is no functioning. So you can do the same process with any number of data. So I have kept the size as 5. You can keep whatever the value that suits you. This is for internal to external. The next program is external to internal. So I can keep the same skeleton. I need to make small changes with that. So here MOV R0 comma 50, let it be, because it's going to be external to internal. We are going to give the input in external, while the output will be obtained in internal memory. So here MOVX at the rate DPTR I'll use. And because like from input has to be given in 4500, so 4500 will have the size of the array, so that will give so since we are accessing it, I am changing that R0 whatever has been mentioned earlier to DPTR over here. Then MOV R1 comma A, the same operation. R1 I am moving with the content of the size of the array. Then incrementing R naught is not necessary initially. So I'll make it as inc dptr over here, because here the size has been fetched, next the data has to be fetched, so inc dptr will be better. Here movx a comma at the rate dptr and mo at the rate r naught, mov at the rate r naught comma a, then here inc r naught, same djnz r1 comma l. So now the program for external to internal is over. External to internal dot asm. So I'll remove the previous file and then add this external to internal. Okay, now let us check the program. Translate, build and rebuild. Start stop debug session. So again same thing is there. So here we are supposed to give the data in 4500, so I'll give 5, and the same data will give, that is 8 9 AB 2155, 8 9 AB 2155. Okay, now R naught is fetched with 50 memory address, then dptr is with 4500, then A is fetched with the 5, that size of the array, then that is transferred to R1 register, that is the size of the memory that we are going to transfer. Then I am incrementing the dptr to 4501, so it is now pointing to 8. 8 is fetched into the accumulator, then 8 is transferred into the internal memory. Now you can see 8 is transferred into the internal memory, the first one. Then I am incrementing the R naught, then decrement R1 and checking whether it has gone to 0. So it has not gone to 0. Again I am repeating the same procedure. 4502, 9 is fetched, 9 is transferred to 51, then AB is transferred to 52, then 21, then 55. So the end of external to internal transfer. So this is for external to internal transfer. Okay, now let us come to the program for external to external, that is from one series of external memory to the other series of external memory we are going to transfer the data. So to do that we'll be assuming two different memory sequences. One is 4500 sequence and another one is 4600 sequence. So we'll start with a fresh one. So we'll close this and we'll remove this. Okay, now as we have done earlier, we'll have to move dptr with hash 4500h, that is the starting memory address, and we'll assume that 4500 is going to be the input memory address. So let that be used for fetching the size of the array. 4500 will be used for fetching the size of the array, while the elements will be available from 4501 2 3 4 5 6, sorry, 1 2 3 4 5, and the result will be obtained in 4600 to 4604. Okay, now mov x a comma at the rate dptr, this is for fetching the size. After the size has been fetched, I'll move it to R1 register, R1 comma A. Then INC dptr INC dptr to go to the next memory address. Yeah, so in this case, to make it simple, rather than putting the datas into 46 starting from 4600, we'll make it as 4601. The result will be obtained from 4601, 2, 3, 4 and 5. So that will make, to make it as 4600, we'll have to have a separate data pointer for that one. That is not possible as far as this particular 8051 is concerned. You have only one DPTR. So what we will do is the result will be directly connecting it with 4501 to 4601, 4502 to 4602. So that will be easier for us. So I'll make it in that way. So I'm incrementing the DPTR. So now again I'll have to fetch the data movx a comma at the rate DPTR. Now the data has been fetched. So next is the fetched data has to be transferred to 4600. To do that, I'll use an instruction mov dph comma hash 46h. So dph is a data pointer higher and dpl is data pointer lower. So I am changing only this data pointer higher to 46. So already the dptr is incremented to 4501. So when I change the value of dph to 46, so from 45 it becomes like 46. So 4601 will be the value of dptr at this instant. So to that I can easily transfer the data movx at the rate dptr comma a. Then I'll have to check whether the values have reached its end. djnz r1 comma l. So l I'll have to make it over here. Okay. Now so this is the this is going to be the end, and after changing the value, we need to rechange the value of the dph mov dph comma hash 45h. So because here we have transferred, and when I'm making it as a loop, again it will be still in 46. So I'll have to change that one. So once this transfer has happened, I'll change it to 45. So again it will increment. So 4502 it will become, from 4502 the data will be transferred, and dph only is changed to 46. So 4602 it will become. So from 2h the data will be transferred. So this is the methodology in which we are going to transfer a data from. So here we'll put L1, yes, jump L1, the end. So external to external dot asm. Okay, now we'll do translate, build and rebuild. So we'll get into start stop debug session. So here uh, memory 2, let it be 45, and this one we'll have to change. We are going to use the same external memory. So x colon 0 x 4600. Okay, now we are supposed to give the input in 4500. So 5 8 9 AB 2155. Okay, so these are the numbers that we are going to transfer it to 4500 to 4601 series. Okay, now DPTR is loaded with 4500, and 5 is fetched into the accumulator, that is transferred into R1 register. Then I am incrementing the DPTR, so it becomes 4501. So from 4501 the data 8 will be fetched into the accumulator. 8 is fetched, so I am changing the DPH to 46. So you can see here 4501 has been changed to 4601. So from accumulator content is 8, I am transferring it into the external memory address. So you can see 4600 is free, and 4601 I am moving the data 8. Then I am decrementing the R1. So I am changing the DPH to 45, that I have done. So 4501 it has become. So again I am decrementing the R1 register, so that I'll keep a track of which memory content is being transferred. Then 4502 9 is fetched from the 4500 series, and I am making it as 4602, so 9 is being transferred into 4602. Subsequently the same operation repeats. So AB is transferred, then 21 is transferred, then 55 is transferred. So all the data has been transferred. So since R1 has reached 0, it comes out of the loop, and that's the end of the program. So this is external to external memory. Next is we'll have to look into code to internal memory. So code to internal memory, it's again similar to external to internal memory transfer. Only thing is we will have to be we'll have to make it clear with the usage of the instruction for accessing the code memory. So we'll get into the program. So we'll do it freshly. So this I'll close, and this I'll remove. So as I have already told you, it's like code to internal memory. So here the code memory address will be accessing through DPTR only. So again DPTR mov DPTR comma hash 4500 I'll do h. Then for internal memory I'll make mov r0 comma hash 50h. Okay, so the 50h is going to be the destination address. So 4500 is going to be the source address. So as we have done earlier, the same operation I can do, like mov x a comma, sorry, it's not movx, it is movc. To access the code memory, we'll have to use this instruction movc. Movx is move from external memory, movc is move from code memory. A comma @a plus dptr. This is the syntax. We can't change the syntax. So always your previous value of accumulator will be added with the dptr to fetch the data. So always when you don't want anything to be added to the dptr, you can always use this instruction clear a, so that your accumulator content will be cleared. So cleared in the sense it will become 0, and dptr, when it is added with 0, so it becomes 4500. So 4500 is accessed, and from there the data is moved into the accumulator. So after that I'll use mov r1 comma a. So this is for keeping the track of, keeping the size of the array that I have to transfer from code to internal. Then next is I'll use inc dptr, then movc, again in this case clr a, movc a comma @a plus dptr. Then after fetching the data has to be transferred to the external memory address. So at mov @r0 comma a. So whatever the data that has been fetched from the code memory will be transferred to the memory address 50. So then we need to check dj nz r1 comma l. So l should be connected to this one. L1 is jump L1. And so this is the program. So here the basic change is movc a, move from the code memory into the accumulator. This we'll have to use. So while using this one, we'll have to be careful, because accumulator content is always added with the dptr to find out the resultant address from where the data has to be fetched. So always, in case in some applications you may need the addition of a as an offset. So for that this will be useful. As far as this particular program is concerned, we are not going to have any offset. So directly we can clear the accumulator and then we can transfer. So this is the program. I'm saving it as code to internal.asm. Okay, now add the file code to internal. Translate, build and rebuild. Then go into start stop debug session. So here let this be I colon 0x50. So internal memory, and let this be code memory. So C colon 0x4500. So inside the code memory we'll put the data 05 05 and same values will give 8 9 AB 21 55. Okay, now we'll run the program. So 4500, I'm initializing it into the dptr, then r0 is loaded with 50. I'm clearing the accumulator. Always while we are starting, we will not have anything inside the accumulator. So we can skip this instruction also, but it is a good practice to always prefix this instruction with CLRA, so that in no point of time this may affect this one, affect the flow of the program. So 5 is fetched into the accumulator, you can see, so that is transferred to R1. Then I am incrementing the DPTR, so it becomes 4501. Then I am clearing the accumulator, you can see. Now it is essential. Here you can't skip the CLR because already 5 is available. 5 will be added with the DPTR. So to avoid that, we'll have to clear the accumulator. Then from 4501, 8 is fetched into the accumulator, and that is transferred into the 50. So 8 is transferred to 50. Then R1 is decremented by 1. Then I am incrementing the DPTR 4502. I am clearing the accumulator and fetching the data 9. 9 is transferred into, okay, we have made a mistake. So we haven't incremented the R1 register. So it is going and making the changes in the same register. So I'll do INC R1. Sorry, R0. INC R0 is essential. Five, 8, 9 AB, 8, 9 AB, 2155. Okay, so again we'll do the same thing. 4500 and 5 is loaded, and the 5 is loaded into the accumulator. Then R1 is having the size of the array. Then I'm incrementing the DPTR, clearing the accumulator, fetching the first value 8, and I am transferring it into the internal memory 50. Then the next value is fetched from 4502. Accumulator is cleared. 9 is transferred to 51. So 51. Then R0 is moved to 52. Then AB is fetched and AB is transferred to the internal memory. Then 21. Then 55. So all the values has been transferred into the internal memory. You can see from here. So this is the pattern in which you can transfer the data from code to internal memory. Okay, in case if you want to move a data or a block of data from code to external memory, then we can simplify the program like this. You can see the previous program what we have discussed, we used R0, so I have removed that one. R0 register is not required. So what we will do is we'll fetch the data from code memory of 4500 to external memory of 4500. So you can have a same memory address between code and external, because the way in which microcontroller accesses the code memory is different from the read-write memory. So it can have the same memory address. So I'm assuming that the both is going to have the same memory address. So I'll initialize only once with 4500. So 4500 of the code memory, I'll be fetching the data and putting the content into the 4500 of external memory. So I am clearing the accumulator, then I am fetching the data. So the first data that is being fetched is the size, so that I am moving it into the R1 register. Then I am incrementing the DPTR, again I am clearing the accumulator, so that the next data is fetched into the accumulator. After fetching the data, I will be directly putting it into the 4500 using MOVX. MOVC is different from MOVX. So but the DPTR is the same. So here when INC DPTR has happened the first time, 4501 will be the content of DPTR. From 4501 code memory, the data will be transferred into the accumulator. So that content is transferred into the 4501 of external memory. Then I am decrementing the R1. So again I am feeding in. In case if we want to have a different memory in the in the different memory in the uh, external memory, that also we can do by manipulating either DPH separately, or we can initialize it and increment it by having a buffer of registers. Those things also we can do. But one thing we'll have to keep it in mind: MOVC at the rate a plus dptr comma a is not possible, because like we are accessing the data from code memory. Code memory is like ROM, so you can access the data from it, but you can't write any data into it while it is, while the program is running. So that we'll have to keep it in mind. Code to external is possible, code to internal is possible, but external to internal, or external to code or internal to code is not possible. So that we'll have to keep it in mind. So these are the different memory transfer programs. Thank you.